Day 24. What do we have here? Collision. Yep. So we've got collision to work with. Now, interesting, okay. So I'm trying to draw what I'm colliding with there, which kind of works, but then, So I'm drawing the offset, but clearly I'm not colliding with that thing, because if I was colliding with that thing, then on the animation there, on the second animation frame, I would go through the wall. So actually, I'm just drawing the offset. I'm not drawing what I'm colliding with. I'm just drawing the offset. Yeah, all right. A lot of to-dos. Yeah, okay, that's good. Now, temp code to draw offset. Yeah, that is what we're drawing. Just the offset. All right. What to-dos do we have just in general? Do we need the offset that's not in the top left? Good question. Don't know. Get from assets. Yeah, well, we can do that now. Kill focus. Kill focus, that's for like Alt Tab. What's next? Handle ground. Collide with more than just the point. Yeah, so I'm colliding with the point on the sprite, and oh yeah, the sprite has a position, and of course the position of the sprite doesn't change when you switch animation frames. So that's why it works as expected. Draw what the collision is against. That would be nice. That would be nice. Special glyphs to draw as sprites. That's for like damage numbers and stuff. Yeah. Temp. Yeah, this is. Well, this is specifically temp code to draw collision lines. Oh my god. Transparent, yeah, good question. I don't know what the answer to that is. Yeah, this is just a temp string hanging out here, that's fine. Yeah, I don't know the answer to that. Temp code to draw offset. Okay, well, so probably the next thing should be to draw more debug stuff, such as what the collision is against. So I'm drawing the offset of the sprite, I'm not drawing what I'm colliding with, which right now is a point. And the point is the collision. Is the position of the sprite. So where is that temp code to draw? What was it? Temp code to draw offset. Draw offset. There it is. Okay, well, I mean, presumably it's like, yeah, it's just that. Hello, chatter. Presumably it's just that, but with a different position. Let's pull that up. Remember me? I do not remember the name, I'm sorry. Pull that out. Yeah, this stuff, I don't know if that's actually helping anybody, so let's just remove that. Misc, alright, static. Rect. Static void, I guess. Draw. Draw point. Yeah. Alright. And really this is so this sprite come on top left thing. Alright, so this would be the raw point. And I guess this doesn't need to be here anymore. So draw point, and this is the point. And what else do we need? Screen rect. Come on. There is another one of these. Yeah, I mean lerp, lerp might actually work fine. Yeah, because it's obvious what the arguments are. So I'll leave it for lerp. Top left rectangle. Okay, so that so it's not a it's a v2 point position, position. Okay, apparently we need the whole game to do world to screen rect. What do we actually need out of game? We need sprite scale multiplier and camera position. Is that it? Maybe I should just take those, right? Like v2 camera position and v2 sprite scale multiplier. No, it's not a v2, it's an f32. Oh my god. ed. Okay, and well, I mean, I guess yeah, let's just take game here. Why not? World to screen rect. This would be, yeah, we're not gonna be taking the whole game here. We're just gonna take camera position and sprite scale multiplier. Yeah. Yep, okay, and in here it would be game, camera position, game, sprite scale multiplier. Okay, apparently we need the window size in there as well. Although, to be fair, we could just take those. Position, camera position, sprite scale multiplier, and then window width, window height. Yeah, not game, but rect translate top left to atlas location offset. Where did we get the atlas location from? No, we just kind of know what it is. Yeah, because that's offset in the in essentially world. Yeah. Yeah, so that is why that kind of works. That's yeah. Actually, that is not really. Mm, yeah, this wouldn't happen here. Game assets atlas location. I mean, we do want to kind of access that rectangle. And then push it into, yeah, I guess we should take the game. We need a lot of stuff out of it. No, we got it. Game camera position. Game sprite scale multiplier. Well, I mean, I guess that's this. We could just take screen offset, I guess. Like screen space offset here. That'll work. Should I just put the window width and height into the game then? Like, do we need to know about it? I mean, it seems to be going along with these things, so maybe. To do. Should window info be in the game struct? Yeah, so there is the white pixel, there is the offsets, there is the color, and then push into the screen rects. Okay, so that position is actually a world position, yeah. And, well, I mean, the way I'm using it, I do kind of want this is position world, but then v2 offset screen. I guess that is how I'm using it. So, yep, and then there is a rect trans is rect translate translated top left rect screen, and then translate by offset screen, pretty much. Point rect. Yeah, I mean the point. Yeah, it's one world unit, so it's a point in that sense. All right. So what are we passing in game? Position world, which is that. Offset screen, which is that. Although, wait. No, well, I mean, it's not. Atlas offsets aren't actually. Wait, no. Atlas offsets, they are in pixels, not in screen pixels. Yeah, because the Atlas doesn't know how big a screen is. So this doesn't. This doesn't actually make sense. Let's remove that part. Let's remove that. let's call this sprite offset position would be what, like v2 add, I guess, position, and then we'll just add this. And then draw where that is. And what do we need there? Window position. Yeah, you know what? Yes. The answer to this question is yes. We will just put it into the window. Into the game. Game window width, game window height. Struct i32 with height window. Yep. Alright. This is assets. Where's the window? Here. Okay, that's not here anymore. Sure. I mean, let's leave this here as is. And whenever we access the width and height, that's now in a different place. Okay, well that is completely different. It is v2. Game camera position, game sprite scale multiplier, game window width, game window height. Like that. Oh wait, this is rect. Yeah. And what do we got here? This is not a window. Well, all of these things. Oh my god. Well, some of these things should be game window, like that, right? These don't really matter. Curious as to when you started to program? About 2018? A lot of the learning I did from Handmade Hero. Okay, what is this error? Ah, it's a pointer. Game window. And game window. just followed Handmade Heroes creators videos. I followed Handmade Hero mostly in 2021, and I followed along with the first 190 episodes, I think. Before that, I mostly programmed in Python and R. Do you work as a software dev? No. I work as a statistician. Right, by compiling. Alright. Yeah, this looks... Well, actually, let's see how this looks. Well, because... I suppose let's look at the shader. That is where... Yeah, that is where the offset is used. Yeah, world unit dimension minus input offset. So that is a world unit. Yeah. Okay, so that we had drawing the correct point, I think, for the sprite offset. Except that what am I actually drawing in? I'm just taking the position. And oops. What? I'm just taking the position and I'm kind of drawing the I'm just adding the offset to that, and that's what I'm drawing. Which of course would mean that it moves, position does, that is. Which is kind of weird, like is that really what wrong? Like, to know where the offset is of the sprite? I think I'm conflating, like that's not what I actually want to be drawing. Draw point. Yeah, I think I just want to draw the position, honestly. Okay. Because that is what collision is with right now. Yeah. Okay, so we are drawing what the collision is with, which right now is just with the point. Okay, so that we are doing. Now, we probably want to do this, collide with more than just a point. Okay, where's the actual collision here? And what are we doing? We're going through the collision lines and just figuring out which one of them we collided with, right? Well, well, to collide with more than just a point, we could presumably just move the walls and collide with the point. Like, those are the same. Although, I suppose you'd have to decide, what does it mean? Like, right now, I think we have we have this greater or equals here, which means inside the wall, when you're inside the wall, and you're going into it, you're not allowed to go into it, but you are allowed to go out of it. And you can have the same rule for if you're just more than just a point. So, like, if a sprite is inside a wall, then you can't go into it, but you can come out of it. Which means, hold on, yeah, that is the collision stuff. Let's just throw a rectangle and a wall. So if this is a sprite and it's inside, which way is the wall? We have directional walls here. There. So you can come out, can't go in, and so if we're colliding with, like, the top left right now, we're colliding with the top left right now, and, well, for this wall specifically, it doesn't, well, for this wall specifically, alright, what do we need to do to be able to collide with the whole rectangle? Well, we need to extend the wall up by, oh my god, by the rectangle. No, they're not connected. They're not connected. They're not connected. Why are you connecting them? For fuck's sake, just come on. So if the wall is extended up by the length of the rectangle, and then we collide with the top left, then that will be equivalent to colliding with the whole rectangle. And as for this situation, I don't think we need to actually do anything here, because right now, if you just collide with the top left, then any move, well, actually we do. Because if you're in this situation, then you shouldn't be able to move into the wall. But the way things are now, you would be allowed to move into the wall, because this thing is outside of it. So, to make that not happen, I guess we can move the wall. Well, it's like you want to... actually, what do you want to do exactly? I guess if you just move the wall... by the length of the rectangle. Okay. I want to select both. So if you move the wall like that, and then collide with the top left, well, that's not gonna work very well. Okay, let's see. What if I move it the other way? Like that. Yeah. Well, now this move is allowed, but it shouldn't be, because the rectangle is inside the wall. I suppose if you're always outside the wall, right? then other than extending the wall up a little bit by the length of the rectangle, there is nothing really that needs to be done to make the collision work. But for the cases, well, for the cases where you're on the other side of the wall, then you can't collide with it at all. So that all works out fine. But the case where you're inside of it, which I suppose is anywhere, if the top left is anywhere from here to here, then that means you're inside. And when you're inside, any move in should be kind of disallowed. Yeah, okay. Let's see. Current bound 1, current wall. Current dot wall normal. So that's this position dot wall normal. So what are we checking there? Less than or equal to 0. To see if we could possibly collide. Well, so that first equality will hold for this wall. For the wall that's moved to the left. Like if we are doing collision against the top left, instead of colliding the top left with this wall, if we collide the top left with this wall, I mean for the purposes of the first equality, then that first one will tell us, first check will tell us if we're in front of the wall or inside, like here in front of the wall or inside the wall. And it's only here that you would be positive, where you're essentially outside the wall completely. Of course, we also used current dot wall normal later, but only once. So because in the second use, it has to be actually, does it have to be? So we want the magnitude of current dot wall normal and new dot wall normal to know where the collision happened. Yeah, that's this expression. So it's in the magnitude of this projection, the magnitude of this projection, and yeah, the resh tells us where the collision happened, and then that collision proportion is used later on. And in the case where you're inside the wall, well, yeah, the collision kind of happens. I mean, you're inside the wall. The collision happens immediately, pretty much. So that should be equivalent. So any one of these should be equivalent to that. Just being inside the wall. So that current dot wall normal is 0. And then we just accept it. And really this is what the whole thing is centered around, is this collision proportion. Alright, so the inside the wall situation really is kind of annoying. You'd think that it wouldn't be such a big deal. Yeah, it is. What if we were colliding with the center? Like in principle, if we were colliding with the center of the rectangle, would it be the same as colliding the point with like these two walls? I suppose, I mean, are both walls relevant? Like at the center, when the center hits here, that's the equivalent of the left edge hitting here. Yeah, so it's only really this wall that's relevant, right? But we're colliding with the top left, so really it's more like it's more like yeah, we have to collide here, so because when the left edge, actually we don't need to move anything anywhere, because when the left edge hits here, well, for this wall specifically, when the left edge hits here, that is the correct collision. And if the left edge is even a little bit inside the wall, then you can just move freely into it. I mean, I suppose that could be the behavior. You happen to somehow be inside the wall and you can just pass through it. I mean, you should never be allowed to be here to begin with, but this is kind of an invalid position, I suppose. And unless there's a simple way to handle that, then maybe we should just not. It's like, even like, yeah, if you have 1 pixel inside, yeah, that's fine, just pass through. So then the only thing that needs to happen is that the left wall would need to grow up by the size of the rectangle. Actually, where is the point that's being collided with? Current to bound 1. Current pause. Current pause is the thing. Current pause is just that. Alright. And well, in addition to current pause, let's say collision dimensions. So colliding with the rectangle. V2 from F32, let's say 5 or 4, sure. So collision dimensions of 4 in each direction. Okay. So then the left wall doesn't need to change. But like, that's just the left wall. What's the general principle here? I guess it's the wall position, Yeah, there is wall bound 1, collision line left. Yeah, so collision line has a reference point. And the length. And that reference point just needs to be moved. Moved by what? Well, the left one doesn't need to move at all. But like the right one, like, oh god. This one would have to move by the size of the rectangle. So now doing collision with the top left on this wall would produce the correct results. Okay, so this needs to move by the size of the rectangle. And presumably it's the same for the top and bottom. Like the top doesn't need to move, the bottom needs to move by the size of the rectangle. Yeah. I mean, we could literally just... But there's only 4 walls. We could just have one of these for each of those. Like, we know the dimensions, right? We know the collision dimensions. The length... Yeah, so if you just take the... like, just have another table, like, which is... like wall shift or something to account for the rectangle. Wall shift. Well, if it blocks from top, then it's just 0. If it blocks from bottom, then that's 0 on the X, and then collision dim Y. Block from left, that's this one, that's collision dim X 0, and block from right is 0 again. That's this one. And then, I mean, this is the only place I'm accessing this left thing. So if I just move wall bound 1 to V2 add, left to wall shift collision line type, then presumably that will kind of work. Maybe? I mean, it did something. I might have shifted it the wrong way or something, but like... block from top. No, block from top is the one that needs to have the shift. Block from bottom does not. Block from left needs to have the shift, and block from right does not. Yeah, of course, we're still passing through visually because we're flipping the sprite over and we're not handling that. Maybe I should put a to-do here about that. Collision does not handle mirroring. So let's just not do that right now. Excuse me. Is there another place? Oh. Oh, well, this shouldn't be happening here anyway, then. By the looks of it. And I suppose this to-do should move like here. Oops. So let's not mirror. Okay. Yeah, so this is colliding as you'd expect it to collide with the position. Yeah, because these walls aren't actually moving anywhere. Now this wall down here moved by whatever, what was it? 4 units or something? Yeah, 4 units. Yeah. So we moved it up by 4 units, by the sprite dimension, by 4 units. So we're colliding a little bit beforehand, and this one we're colliding afterwards, because I didn't move it the right way. It needs to move to the left. So that one moved up, and we are bottom up in world space, which another to do, I suppose. Should world space be bottom up or top down? To think about that. Yeah, so there it is. That's fine, and I still haven't fixed that. Hold on. That's negative x here. Negative x. Yeah. Well, I kind of need to draw the rectangle though. That would be nice. Actually, don't I draw point, draw glyph, draw stir? I don't have a draw rect or anything. Draw. No. Interesting. Okay. Well. Let's draw a rectangle. And that's what's happening here, really. So maybe I should just do draw rect. And then pass it, what, the game and the rectangle. So just that. And then it would be essentially the same as that, right? So draw rect. Actually, this would even be more general, because really this is just a draw rect. But like the rect is v2 from f32 1. Like that's really all that is. Rect world. There it is. Oops. course, I'm not specifying colors, so I guess this is more of a to-do for this place. Okay, so we should be able to draw. Yeah, so now they're all magenta. I suppose we should pass in the color. V4 color, and color white, I guess. I mean, does that actually help? V4 or yeah, I mean it's not really that much work to just define one, right? 1, 1, 1, 1, like that's obviously white. Oops. Color is that. And here we should just pass color through. In this manner. It works. Yeah, so the draw point one makes sense where it is, but the other one doesn't. Oh yeah, alright. V4. RB. Something like this. What's sub-object? What are you talking about? There's no sub-object. I mean, meh. Okay. Yeah, so we draw now we can draw the collision shape properly. Like, where is that draw point? Draw point. Okay, well, so draw point doesn't have to be a draw point anymore. It can be a draw rect instead. And the rectangle is that, and then the whatever arbitrary dimensions they gave to the V2 from like 32 4 or something. Yeah. Okay, so is that what we're colliding with? Seemingly so. Except that here we're allowing it to go in, and here we're not. Is that consistent? Yeah, seemingly so. Unless, of course, the drawing is incorrect. Which could also happen. Well, I guess if the dimensions are 1, then that kind of is a point, right? So yeah, because we were already colliding with I mean, maybe we should shift these walls by 1 to make it so the collision happens, to make it so the collision shape does not go inside the wall, at least visually. So is that 4 world units though? Yeah, I think so. Do we have? Nope, that's not. Okay, well that is one world unit, it's 1 pixel. So it seems like, yeah, we have 4 of those. Yeah, it is 4 world units, so we're drawing it correctly. So perhaps then I should move the walls around a little bit more. So bottom would need to move down by 1, and right would need, block from right would need to move to the right by 1. But wait, block from bottom. Yeah, move to the right. Let's see. Yeah, okay, well, the walls are actually infinitely thin, aren't they? Like, these are just drawings of walls. And of course the drawings of walls aren't infinitely thin because you won't see them. But yeah, this wall is actually like on this edge. And this wall is like on this top edge. Pretty much. Yeah. So no, the collision actually is working as intended there. If you treat walls as being infinitely thin. It's just you need to keep in mind which edge of the wall is the actual collision plane. So this is more of a question of how to draw walls than it is anything else. And well, I mean, might as well address that. And draw the walls in a less confusing way. Collision rectangle, top left, collision line left. Yeah, okay, well, see, for the bottom and the right walls, that makes sense. But then for the other two, it doesn't so much. So this is the dimensions, that's fine. Whoops. Needs shift. Collision type is block from right. Oops. Collision type is block from top, from bottom. If needs shift, then collision line rect world top left needs to be shifted. Well, I mean, actually it needs to be shifted differently, right? Yeah. So if it's a block from right wall, then oh my god, then top left x needs to be moved left. X minus equals whatever the dimension is. Collision line rect world dimension x. So just move it to the left. Yeah, and the top, do the same to the top. Block from bottom. So this is top left y, and that needs to be moved up. Dim y. Yeah. Okay, so now we have the little corner there, which does make sense because it's the collision plane that we have drawing. Okay, so well, collision is working. rectangle. Although, is it working though? Hold on. Like, not really, right? Not fully. Because one part of it is working, but there is the other part, which is yeah, so these walls are working completely fully. Actually, well, not fully. Yeah, so that part, the wall needs to be extended by an appropriate amount. So the length needs to be modified as well. The length of the wall. F32 wall extension. Collision line type. Actually, no, yeah, it does have to be. Well, does it? So wall shift. So if it blocks from top, then the blocks from top. It's like bottom wall. So bottom wall blocks from top. We're colliding with this thing, so we move it up. And the other thing that we need to do, we don't need to move it to the left, but we do need to extend it to the right. If it blocks from bottom, it's the same. We need to like extend it to the right. Okay, so and is it the same for these vertical walls? Like, we don't need to move it up or anything, and we don't need to move this up either. But we do need to extend. So in either case, it's just extension. It's just the extension thing. Yeah, and we already have wall unit vector. And if we just multiply the wall unit vector, well, actually, if we dot the wall unit vector with the dimensions of the so block from top, block from bottom, that will take the x, and that will be a positive x, and it will extend it to the right by that number, which is correct. For these walls, it will be a negative y, so it will, that is also correct actually. Yeah. So yeah, so it's wall unit vector scaled up by collision line length, except that the collision line length itself needs to be extended by well, that's the thing, it needs to be extended. And if you just dot it, v2 dot wall unit vector and collision, what's the dimensions? So this is a number. Yeah, we kind of need the absolute value of that. And if you just add that to the length, that will presumably well, actually, hold on, this No, this specifically doesn't need to be extended. It needs to be moved to the left. Yeah, we're not even really testing that here. Alright, so not all of them need to be extended. Okay, so this does apply to some of them, but not all of them. The top wall, it does need to be moved to the left. Well, actually, hold on. If you move it to the left, then you do need to extend it. By that amount. So yeah, so if it blocks from top, then it needs to be moved to the left by collision dim X. And if it blocks from bottom, it also needs to be moved to the left by collision dim X. If it blocks from left or right, then we do not need to oops. Yeah, so this one does, like, you know, for this collision to make sense, we need to move it to the left. Yeah, but this one, we don't need to move it up. Actually, but we do need to move it up. Yeah, we do need to move it up and extend it. Well, up means positive y, so by collision dim y. So left and right both move up, like that. So this should still be, okay, so the movement needs to, okay, let's just change the movement real quick. Delta x if input keys accelerate down, delta x times equals 10. Okay, we don't have that input key, so accelerate. Yeah. VK shift. Okay, so now we are moving slowly. Okay, there it is. Okay, so we can, well, we can't collide side on with the wall like that. That's by design. Okay, so we're colliding here. We seem to be colliding correctly. Okay, that's correct. That's correct. That's correct. Those two walls need to move up. I mean, we need more of them, I suppose, to make sure they're correct on both sides. Yeah. Okay, rectangular collision is working now. We need more walls though. So block from top, that's fine. Block from left is fine. Block from bottom, we need two of those. minus 100. Well, let's put one at 0, I guess. Yeah. That works. That also works. And block from right, let's make 2 of those. Yeah, that works. That also works, okay. And this works, okay. Okay. Let's re-enable mirroring. I mean, I suppose, it doesn't really matter what the sprite is doing. What matters is what the collision shape is doing. And the collision shape is colliding. Appropriately. So we are doing this. Okay, now the problem, though, is that we just kind of have this collision dimension here. And where is that supposed to be? Is the question. So far, okay, we have sprite. Okay, sprites don't have a dimension, interestingly. That's common. Okay. Common entity animation frame, Yeah. Yeah, I suppose it's these things really that have collision dimensions. Of course, those collision dimensions don't necessarily go from the top left of the sprite. But I guess we can adopt the convention that top left is just not the top left. Well, but oh god. There is a discrepancy between the visual representation of the sprite and the collision shape of the sprite, and those two need to be reconciled somehow. And this top left right now refers to the visual top left. Well, it doesn't even really do that, does it? It's the visual top left after the offset. After the offset has been applied. Yeah, so this top left is... it doesn't really mean much of anything, come to think of it. It's just kind of... sometimes it's the top left. But sometimes it's like the offset top left, depending on what sprite texture is being used. So that needs to be sorted out. Yeah, offset position top left plus offset. I guess this is more like a reference position or something. Which is... that's what it used to be called. It used to be just called position. Nice and ambiguous. Although, but it is ambiguous though, because the sprite will have a visual representation which changes, but also a collision shape which may change. So like a position, like, well, which position are you referring to? I mean, just some kind of a reference somewhere in there. So maybe I should just call it position, I don't know. I'm gonna go take a toilet break. Mute. Let's see. Let's see. So perhaps... Alright, so I'll just add some to-dos and commit what I have. So we've got these collision dimensions. Where should this live? And then collision line, no. Where I'm drawing the collision shape. Where is that happening? Yeah, I suppose this is also a temp. Temp collision shape drawing. And of course, you know, it's got this hard-coded dimension here because we don't really know where to store that right now. Okay, so that compiles, runs, and so on. Alright, so let's commit it. Yeah, let's load the screen, that's fine. Moved that out, that's fine. Added more walls. Changed the frame, that's fine. Add dimensions. Well, actually, hold on. The dimensions are the same, which is kind of a problem. They should be different from v2 from v2. Let's say 3 and 6 or something like that. And of course we have to change it in the other place. Okay, so that is now the collision shape, so it works correctly here. And it seems to work correctly here. Yep. And here, yeah. That's fine. That's fine. That's fine. That's fine. Yeah. Add dimensions to the collision shape. I suppose it makes sense to figure out where to store those dimensions, and I've added them. Also, the other thing, so this top left, I guess I can put a note here explaining what that is. This is like the visual top left of the sprite in its like first frame in the first frame of any animation, which I guess assumes that every animation is aligned with every other animation on that first frame. Which is an interesting assumption. I suppose, okay. Well, well, it might actually be a good assumption to make, though, because if the animations are not aligned on the first frame, then you're gonna have to store alignment information somewhere in the art anyway. And if you're gonna store alignment information in the art, is that really easier than just aligning the art? Probably not. Animation first frames of all animations for a given sprite are aligned with each other. This is the visual top left frame of any animation. First frames of all animations. Okay. Alright, so that's fine. That part is taken care of. Now, collision shape. Okay, so sprites can have different positions, but if different sprites are of the same entity, then presumably they have the same collision geometry. Or at least the same reference collision geometry. And if it never changes, then yeah, it's the same collision geometry. And which for now, nothing, collision shapes aren't going to be changing for now. So I guess it needs to be stored in the assets. That's kind of the property of an asset, maybe. Yeah, it's like we have, what do we have in the asset data? Well, we've got, yeah, so we've got animations, right? And just like sprites have animations, they can also have collision rectangles. And that collision rectangle can be per entity, or it can be different for every entity, for every animation of that entity. Either way, no, yeah, not sure if that really works, and it really makes sense to change them per. I mean, we can start with just one rectangle per entity and see how that goes. Of course, that has to come from somewhere, and presumably we can define that in the art. But before we even do that, like right now we just have this collision. We have this collision dimension, right? But we can also have a collision, I guess, collision offset? Like a collision offset from, well, let's see how it goes. V2 collision offset. V2, you know, like 2, 3, let's say. And that's like collision offset from this current position. Okay, so current position is used. Okay, so it's used in all sorts of places. Okay, so I guess the first thing we can do is just say, well, collision is to offset it by that amount. There. V2 collision offset is V2, well, I need that 2, 3, let's say. Collision offset. Collision dimension. Yeah, suppose this to do applies to both of these. Yeah, so that's the current position, is just the top left. Well, yeah, the so-called top left, which is the visual top left in the reference frame, first frame. That top left. And you add the offset, and that's the point, the collision point that we're going to be moving around. And then at the end, this current pause, well, we need to do the opposite. Collision offset. So we added the offset, now we're subtracting the offset. Okay. Yeah, let's just take them out to like here. And wherever I'm drawing the collision shapes, which is weirdly not where it's supposed to be. I think like it's weirdly here. Yeah, here is where I'm drawing the collision shapes. Yeah, probably because I'm iterating through the sprites. I mean, all we really have to do is to iterate through the sprites. Right? Okay, so V2 add, sprite common top left, collision offset, and this is collision dim. Did I call it some weird? Collision offset. Collision offset. Collision offset. Okay, so presumably now it's offset a little bit from where it used to be. Although it's offset up apparently. Well, presumably we'll offset it down. Yeah, so like we want it to be just in an arbitrary location, and of course we're not handling mirroring at all. But at least for non-mirrored, so this would be the kind of collision shape that would make a lot more sense for this sprite specifically. And we do seem to be fine in terms of how that's being handled. Yeah, it seems to be handled correctly. Of course, we could just mirror stuff across the midline rather than across the left line. And then And then this wouldn't be so much of a problem. Maybe I should just do that. Let's say mirror X. Yeah, that's all in the shader. Well, it's only really used in two places. One is to, so this second one we don't need to worry about really, because we are sampling correctly. It's only really this one that's, I guess, problematic. Like, what if we turn that off? Huh, interesting. Well, now it is flipping. Yeah, it essentially is flipping around the center. But like the center is, like the center of the sprite is where that arm comes out. And that's what it's flipping around. Yeah. So, yeah, I mean, so, well, you can't just teleport the collision shape, right? So, I suppose it needs to flip in such a way that, like, across the center of the collision shape or something like that. Like, so wherever the collision shape happens to be, that's what we want to flip around. Dimension and world units. That is the center. Okay, let's see. So it's like given a sprite. Given a sprite. We've got, like, how do we mirror it? Like, it's got some asymmetry to it, right? So we should be able to mirror it along an arbitrary line, and right now what we're doing is we're looking at the offset, right? And I'm just turning it into an offset for center. So offset from the center of the sprite to whatever the reference point is. So like if this is the offset, and we've got the center here, so we just kind of come up with this vector, which is the offset for center. Flip the y, and offset for center. Well, Actually, how am I interpreting all this stuff? So we have the offset that we're passing in here, and I'm simply turning it into an offset to center by taking the half dimension and subtracting it from it. So for when this is like in the corner, then this is just negative, negative. Well, it's flipped. So yeah. When this is 0, 0, then this ends up being negative, well, actually positive x and negative y. This ends up being positive x and negative y. It ends up being that. That is the offset for center, which means that the center needs to move to the right, well, to the right. Unless you're mirroring, in which case, yeah, because positive offset on the x means that we need to move to the right. I think that's the idea here. Yeah, positive offset on the x means we need to move the whole, wait. No, it means we need to move to the left, doesn't it? Oh my god. Yeah, we're subtracting it, so if the if the offset is 0, 0, then offset for center is half dimensions. Offset for center x is half of the dimension of x, which means that the center will move to the right. Which means that this rectangle will move to the right. Okay, so that's what the offset. Okay, all right. So, yeah, okay. That's why I'm doing the offset for center. Yeah, that does make sense. Okay, so this offset really is just used to like align animations to each other. And okay, how does mirroring interact with it? When you mirror, I'm simply taking the offset for center x and multiplying by -1. So I'm kind of coupling the concept of aligning animations together and mirroring the sprite. And maybe that's not what we need to do here. It's like if you have a sprite with an offset here, well, with the offset of 0, 0, then when you mirror it, yeah, there should be, like, each sprite should have a different offset, which is like the mirroring offset. And that only that only happens for some, like for some sprites, it's a one-dimensional construct, because we're not going to be flipping everything across both dimensions. Yeah, so like for this sprite, for the commander sprite, we should just define where the flip line is for it, and flip along that on the x-axis. I mean, we could even just open just the idle one, right? And just say, well, like here approximately is where you wanna, so 1, 2, like two pixels in relative to the stop left thing, like 2 pixels in, you would want the flip to happen. And what does that mean? It's like, given that we have some line that's like, okay, we're gonna flip along here. And that means that once you flip, you kind of want this to be the result. Yeah, so it like the visual, like if you outline the whole visual rectangle, it essentially ends up moving, the visual rectangle ends up moving to the left somewhat. So if this is 2 pixels in, then this ends up being 2 pixels here, right? So then, okay, so this line needs to change. So instead of, so we have some offset for center, which is like, okay, so if we're not mirroring, oh god, if we're not mirroring, then the offset, then the rectangle needs to be translated by this much. And that's that. If we are mirroring though, well, let's see, if if the flip line is the left edge, then, well, you need to move it, you need to take whatever position you would have and move it over by half dimension plus half dimension, like by the whole dimension. If it's in the center, then you wouldn't move it at all. If it's like quarter way, then you would move it by quarter. You can like you move by quarter and then by another quarter. I see. So if input mirror x, then offset for center x. Okay, so it's not a multiplied by -1. Instead, we just we just need to add the okay, the relevant distance is the distance from the center to the flip line. Float flip line x is, let's say, 2. So we're in world units. So if flip line x is 2 units in, we just take half dimension x minus this to get this distance from the center to the line. Float 2 half world unit dim is that. flip line x is 2. Pass in. Okay, so okay, there's a few computations here. So if we are mirroring, then we take the half dimension and we subtract flip line x. And what does this tell us? This tells us this minus that. So it tells us the distance from center to flip line. And then offset for center x. Well, it needs to be moved to the left, presumably. World unit. Well, let's see. World unit minus flip line. So in this situation, this would be a positive number, but we want to move to the left, so we want to subtract twice that. Minus equals 2 times center to flip line. So in this case, this would just be half twice. And in this case, it would just be 0 twice. So just that. Yeah, of course, the offset gets all messed up. I mean, the animations get all messed up. But other than the animations being messed up, I think this is doing what it's supposed to be doing. And now, why are the animations messed up? So they're aligned here, but then they're messed up here. Well, if the sprite is flipped, then so is its... Then that offset that we added. So we've added this offset to align the animations, and I've yeah, so I've subtracted it here. Because positive means we need to move 0, 0, yeah. And I've subtracted it here. But for a flipped sprite, yeah, so it's like the offset is actually different. Because like if the offset was, let's say, on the left edge, then once you flip, well, once you flip it, it's here, right? but then you switch to a different animation frame where the offset is like over here. And this flip line, does that mean that we can just move the flip line and it will work? So let's say it's 2 in the reference orientation, and if we look at the walk, so if it's 2 in the reference frame, the first frame, then it's gonna be like well, plus this, which is the x offset. So if we just move the flip line, then presumably plus input offset x, like that. Yeah, we can just move the flip line. Yeah, and okay, so that's what it means. So we can see here what it means to be flipping around 2. So there is 1, 2. So 2 is where the edge of the head is. Apparently. And this is 1, this is 2. And we're flipping around the left edge of that. Interesting. Oh yeah, because we have the transparent border. So everything is actually bigger by 1. So flipping around 2. So that the left edge of the head ends up being aligned in either case. But it should presumably flip such that the body stays like, what if we flip around 3? Does that do what I expect it to do? Kind of. Now the body is in mostly the same position. So, yeah, this is approximately what we want. Of course, the flip line, the position of the flip line needs to be defined, not in the shader. The offset is already defined by the art, so that's fine. The flip line needs to be defined by the art as well, somehow, presumably. And yeah, so this 3 is what needs to be passed in. And the flip line needs to be defined by the art. And the collision shape needs to be defined by the art. Yeah, so those are the next things to do, is define the flip line and define the collision shape in the art. Then export it into the assets, load it, and use it. Of course, the flip line, that's kind of a per entity concept. So, like, art is per animation, not per entity. And so defining the same flip line in every single animation, that doesn't really make sense, right? Same with collision lines, actually. That's if that's a per entity thing and not a per animation thing. Well, I suppose I can just define all of that in idle. And then just say, well, that is the collision shape in idle, that is the flip line in idle. And then every other animation just aligns to that. Yeah, that'll probably work fine. Okay. Well, I mean, I know where this should live. A store in assets per entity. And this is just me saying, yes, so basically I just added a collision offset. Okay. Well, that's all for today. Thanks everyone.